why build, deploy. And what I'm going to show is a Lakebase-powered apps on Databricks. Imagine for a second that you work for a drug manufacturing company as a clinical trial coordinator, right? And the trial is being conducted for over 25,000 people worldwide. And as a clinical trial coordinator, you will record some patient trial data into a web app that has been built for you and many other coordinators across the world just like you. And so when you have all that data, when you input all that data in the web app, you also need some of the insights from that data to sort of achieve some of your goals. And what are those goals? They are things like detecting any issues with the trial. If the trial is not being run properly, you identify some issues with it. Managing any patient safety. So maybe if the patients are reporting, maybe for example, certain age group has particular reaction to the medication, right? So you want to make sure that is also taken care of. And be also mindful of any protocol compliance, right? If you are in a healthcare industry, it's highly regulated and you want to be mindful of that. So when you have something like this, a typical enterprise data architecture would look something like what I have here. So the way it would start is this is you, a coordinator. This is the web app or the application or the front end that has been set up for you. Then you interact with this web app, you enter the patient data. This gets sent to an OLTP, which is a transactional database or transactional processing system. Over the period of time, let's say over a week, over a month, or whatever window, you pull that data out from that OLTP system into an analytics processing system, right? This is very standard, nothing fancy. I mean, I have simplified this flow, but more or less, it's pretty much the same. You pull the data from your OLTP system into your OLAP system. You run a whole bunch of ML models, analytics, prediction, forecasting. I mean, the whole 9 yards here. And then at the end of that analytics process, you kind of generate some sort of refined data, right? Something that can be used as insight to the end user. So what you do, you push that back into the OLTP system, and then the same app which you use to input the data can pull the insights from the OLTP system and then show it to the end user, right? Which is you in this case, coordinator. So basically, it boils down to the fact that the more seamlessly your steps 3, 4, and 5, the ETL, the analytics processing, and the reverse ETL, basically it is ETL, but for the sake of this discussion, we call it reverse ETL. So the more seamless this process 3, 4, and 5 are executed, the more efficiently your goals are achieved, right? If you have problems here, you will see what happens. Now you have some technical challenges here. I have the same architecture diagram here for your reference as well. So the first challenge itself is you have to manage multiple systems. You have your web app with its authentication system. You have your OLTP with its own governance model. You have your OLAP with its own governance model. And then you have a bunch of ETL pipelines. You have some sort of transactions, API calls, authentication, and everything. Multiple systems to manage. Data synchronization. You are pulling critical data, healthcare-related data. You want insights as soon as you can, practically get it. As soon as you generate it, you want it to be shown to the end user. If something goes wrong here, your insights are delayed, your data processing is delayed. Challenge with AI/ML integration. All these three systems are generally siloed in the sense that they are their own independent systems, right? So when you bring them together, for example, the web app hosting service, the OLTP service, the database service there, and then OLAP service like Databricks. So when you build an architecture like this, you hope that all of these three components play well with each other, right? You get some connectors, you get the authentication and everything in place. The fourth and the fifth point are pretty much the same. They have the separate governance model. So on the OLAP system, you manage your user access, the data access in a separate way, in a separate manner than you would do it on the OLTP system. So basically, what is happening is, I mean, in addition to all of that, what we are seeing is, with all the recent AI development and stuff, the analytics, operational, and the application system. So the three components that we saw earlier, they are starting to converge. And this is my way of showing that it's converging, but anyway. So, but as we saw earlier, that there is a disconnect between the three layers. So there are separate processes that need to be done in order to have all these things, process seamlessly. And so after Databricks, I mean, again, after Databricks solved the whole analytical processing challenge, the next challenge was that we decided to kind of embark on was, how do we bring all of this together with almost zero friction between all these layers? And so for there is what we are bringing the Databricks Lakebase. What is this? Point number one, it's a fully managed Postgres database. Again, OLTP, but nothing fancy here. Second, it's built on top of Neon. I don't know how many of you know about Neon, but there used to be a company called Neon. It got recently acquired by Databricks. Again, nothing too fancy there. We have seen companies getting acquired in the past. I really want you to focus on point number 3, 4, and 5. What makes Lakebase special and kind of a game changer is its native integration with the Lakehouse. So you have your OLAP system, the analytics processing system. The entire OLTP system is kind of natively integrated with it. So what it simply means, rather, I'll show you what it means. Decoupled compute and storage. So again, just like you have Lakehouse, where you have decoupled compute and storage, it also makes sense that we continue working on the same philosophy, that even if it's an OLTP system, where a lot of the times the compute and the storage are kind of coupled, we don't want to do that. If we can have them decoupled, why not? And I think the last one is probably one of the most important things. Again, modern developer experience for AI. And again, a lot of people talk about AI. We have some numbers as well. So the company that Databricks acquired, we saw they reported us a very interesting number. And so between October 24, from October 24 to May 2025, when the whole AI agents and everything like really kicked off, what we saw was the AI agents were creating 4 times more databases than humans. And this was being done on Neon. So this kind of gave us clarity about 2 things. Number one, if you want to have an OLTP system built for the future, you need to have it built in a way that makes it suitable and it treats AI systems as first-class citizens. You don't want to do some sort of patchwork where you already have an OLTP system and then you kind of try to force it to work with all these AI agents and whatnot. So, yeah. Okay, now coming back to the Lakebase, what kind of workloads does it enable? So the first two are similar. The number one is online feature store. Number two is data serving to application. What it basically means is you have your analytics platform. You do a whole bunch of things here. You generate some interesting data, insightful data, and you want to push it to your OLTP system. And once you have that data in OLTP system, that can be then fetched by your ML models or applications. So that's one kind of workload, but they're essentially two workloads. The third one, I think we have already seen this. You have your analytics platform. You have some application. It's generating some data, storing it in OLTP. You want to pull that data from the OLTP system, process it. Nothing fancy there. This is And again, one of the most important things here is I don't use any of the default or Databricks sponsored, architecture diagrams and whatnot. This is my own understanding. This is my own experimentation with the entire architecture. So what is happening and what I believe is the future of enterprise data architecture would look more and more like this. With a single governance model, you are taking care of Lakehouse, Lakebase, so basically OLAP, OLTP, and the application layer. You don't need three different governance layer. Similarly, all these three things are now being basically developed and deployed under one single umbrella, that is your intelligence platform. So you don't have to manage three different systems. You don't have to worry about any of the other things. So in short, what are the advantages? Earlier, you had multiple systems to manage. It all comes down, it all boils to one single system. You had a problem of data synchronization where you had to build complex ETL pipelines. No, you don't have to do that. All of that is already being taken care of. You have data in your OLTP system. It gets pulled automatically. You have the option to have that data pulling triggered at certain intervals, so you can do it continuously. Challenges with AI ML integration because everything is on a single platform. The moment you have the data, you pull the data into your OLTP system, you can actually start running your AI ML models, and you don't have to kind of have different endpoints and make different API calls and all of that. Separate governance model and separate user authentication, all of that goes away. You have like a unified model and uniform governance and uniform authentication models. Now, let's do a demo. One of the things that I believe is, talk is too much. It can be tiring, but unless I show you, what uh, it all means, it does not hold any ground. So what I was trying to tell you is, let's say you were that coordinator and you had this platform in front of you. I jumped to the wrong tab, but so with the patient directory, when you conduct a whole bunch of trials on different patients, the patients will come back and they will tell you, they will occasionally report their problems, not occasionally, but maybe routinely. So what you will do is so let's look at this right now. So you have 40 patients reported something, you have these insights, you have some of these things, but just look at the number 40. And let's hope that the demo goes well. So let's say a patient comes in, you are like doing all of this, say some feedback, the patient says, okay, I don't feel good, some site location, you basically enter a whole bunch of information. And then you click submit. And so one important thing here is it's not just you who is doing this. There are hundreds and maybe thousands of trial coordinators who are doing this similar information. And so what's important is the moment this information or anybody across the world reports an issue, it should get sent out to every single trial coordinator, right? So for example, I say, you know what, this medication, somewhere in maybe Asia, somebody found out that this particular medication is having a very negative impact on maybe teenagers, right? So you want that to be brought up immediately. That is one. And you want people to watch out for it. So how do you do that? You will be able to do that when you have that seamless integration of things where the insights are being generated as soon as the data gets generated. So you saw we had that. We inserted that record, we submitted the data. How do we know that the data actually went in? You look at the last record. I will zoom in. So the last record we entered was this random value. uh, I don't think there's need to zoom in further, but what is happening is this is a proof enough that the data that I'm entering on the front end, it's going on the back end, and this is an OLTP system. So Databricks was never known for having an OLTP system. Databricks was more of an OLAP system, the analytics processing system. But the fact that you have now natively have all these things built in, that is one big thing. So you don't have to jump across different tabs and do a whole bunch of those things. Now, the moment I have this, what I know is the data is in my OLTP. The next is you want to have that data go through your entire process of analytics and then generate some sort of insights. So how do you do that? I have built this pipeline, and what I will do is I will run it now. Again, you could have this pipeline run continuously in a streaming manner, which basically means that it will watch out for any record from anybody across the world. And if there is any sort of weird behavior, it would immediately point it out. But again, you can think this is, again, one case where this may not be appropriate. You are fine when you are working in healthcare. You may be fine with getting, maybe data or insights every 1 or 2 hours. But if you think of an industry where you need data, maybe insights immediately, then you kind of turn this from batch to streaming mode. So what is happening inside this? So you have one step here that says extract from Lakebase. Basically, the data is an OLTP, it's extracting. Next is clinical trial data processing. Now, what is this fancy thing? This fancy thing, I will show you from a run that has already completed, is this complex workflow. Now, this is not a workflow which I could have just run, while getting the data. Maybe I'm running some, complex sentiment analysis models and a whole bunch of things. So this is like a big workflow that I'm running. And once the workflow finishes running, I want all of that insight to then go back to the Lakebase. And this is where the Lakebase kind of pushes all the updates into the OLTP layer, or Databricks pushes the updates in the OLTP layer. So now, hopefully, let's see, where is this guy? Okay, so it's running on the second stage, and in a couple of minutes, it will end up pushing the data to the last stage. So I think the idea here is, and yeah, so you have seen Lakehouse, where all the analytics happens. You have seen the Lakebase, where all your transactional data stays. The last thing that I mentioned was you have now the capability to host all your apps right on one single platform as well. So essentially what has happened is, earlier when you had all this architecture, we have literally seen companies spend hundreds of thousands of dollars to kind of invest in each of these systems separately, right? And then you not only that is an investment, but then you have to get an appropriate skill set to kind of develop things on top of those systems that you have in place. With what we have developed, you kind of have one master system sort of a thing, kind of a cohesive system, which kind of where everything works with each other, and then you kind of get all the results that you are expecting. So the important thing here is this part. So what happened is the CDC is basically change data capture. When I ran this pipeline, it immediately picked that there was one new record, and then it kind of made it, pushed it forward to other layers. So all of these are streaming tables and whatnot. I mean, we don't really need to get into those technicalities. And so this thing has finished. And so what has happened is, if I refresh the page, hopefully the 40 should turn 41. So what it simply means is within a span of about 2 to 3 minutes. And this is when I had batch processing, right? Within the span of 2 to 3 minutes, I had the data get generated, the data get processed, insights generated, then presented to the end user, right? And again, you are free to generate whatever kind of fancy charts you want. I mean, a lot of them don't make sense because I've just played with it. But if you think of certain use case where you can have this sort of loop, then what ultimately happens, two things: save a lot of effort, save a lot of money. Why? Effort, I built this entire thing in about 1.5 days. You would usually have companies set up this entire thing. You would have extensive teams going in. One would develop the app, one would do the whole thing. It's kind of crazy how we have come this far. And I would be very wrong if I said it's all Databricks who did it. No, the other thing is where the vibe coding part comes in. Out of everything that I have developed so far, so I built the app, I built the code for the data processing and everything, I did not honestly write a single line of code. Everything was kind of done by me in, I don't know how many people here have heard of an IDE called Cursor. So Cursor is an IDE which has built-in support for AI models and everything, basically ChatGPT into a developer environment. So I don't know if let me see. I'll just take one more minute, hopefully. So where are you, my cursor? Nope, probably not. Oh, there you go. Share. So, dear God. So basically what is happening is if I said something like, so on the right-hand side, I know you don't need to read what's happening. On the left-hand side, I have all my files. On the right-hand side are all my chat interactions with Cursor. So I don't have to say, I don't have to write any code. All I say is, for example, if I was like, make the theme, what is it called? Dark theme, and what is the other? Or what? Sure, white. Make the theme white. I mean, this will probably break the app. It will make it look horrible because I have not given it any additional uh, information as to what should be the colors and whatnot. But basically what it did here, if you see, it first made changes to the app code. That's one. Then it uploaded my web app data to Databricks, and then it also deployed it, and then it gives me a good overview of what it did. So basically, I did not have to do anything apart from saying do this. And you see now the app, it's kind of messed up, but you see the theme is switched from dark mode to the white mode, right? So again, I am not sharing that screen. That's why you are not able to see it. Last 30 seconds. So this is what it becomes, right? All I said was change to white mode or whatever I said, and it turned it into this. If I don't like it, I'll say go back to what you had earlier. It will take it back. So the idea is when you have a good platform, a data platform, and when you have these sort of tools, the development work really shrinks, right? 1.5 day, I'm not kidding. I took more time working on these slides than actually building the system, building the entire system. So I had the OLAP, the OLTP, and the web app, everything done, set up. And then I was thinking, what should I put in my slides? And so that's where I decided to kind of handcraft these things and the solution. So yeah, that's the demo. That's everything that I had to show. Hopefully this was not too boring. If you have any questions, please feel free to ask me. Otherwise, yeah, feel free to connect with me on LinkedIn. Yeah, go ahead.